Ah, hello, hello. Hi. I hope I'm audible. Hi, hello. Welcome to the stream. Okay, so we are live, and today we will start solving greedy problems because uh, both for DP and graph, as we have solved more and more questions of them, we have come across harder topics, which is not really necessary for I think most of the interviews, and we will instead of doing that, I thought maybe I should focus more on the variety of problems that we can do in the time. Okay, so after DP and graph, uh, we can jump to range queries, but it is not really that. But it is not really asked in the interviews that much. So maybe we'll do this sorting, searching, and introductory problems first, and then of course there will come a time when we will solve all the remaining DP and graph problems as well. After I learned the concepts and solved some problems on them. Okay. So yesterday we started the sorting and searching problems, and we solved two problems in this, I think. Okay, so let me create a new board now that we have started greedy. So I will save this as greedy. Okay, this is the greedy. And the first one that we are going to solve is listing numbers. This I solved yesterday. It is basically nothing but just using a map and then then returning the size. So not really, you know, deserve. It doesn't really deserve a. Okay, it doesn't really deserve a entire section of this video dedicated to it. So, or maybe should we do it? If I'm anyway documenting all this now, I think I should do it. Or maybe I can just go through the question. No, I don't have it. Oh no, I can go through the solutions that are submitted. It. So I did nothing. Just I had a set here, and all the numbers in the stream that I was given, I just inserted that in the set, and then at the end of the code, I returned the size of the set. So it will give the digital numbers. For apartments, this I'm still not sure. I tried doing some two pointer sorting and searching, but there were two or three test cases which failed, so I'm not sure. Okay, and also one thing I need to, I mean, search is, sorry, uh, how to prove greedy solutions. I don't know how to prove the greedy solutions. I don't have the mindset for it. really. And there are a lot of specific type of greedy standard problems that I have not solved. I know of them. I have read about them in a book. I think Guide to CP or something. But it was like 2 years back. I forgot. So there are some, but I need to relearn some of these things. I've not forgotten it. I can't recall it right now. Okay, like this interval scheduling and all that. Yeah, this. This is okay. Okay, so this is for a specific problem, I think. But for this apartment one, so what my, you know, what my logic was. Okay, so uh, the approach I used was very simple actually. So we are given two things. So three things basically. We are given an array of what apartment size the customer want. Okay, uh, here desired size of the desired apartment size. So let's call it A. So A is basically uh, desired apartment AI size. Okay, then we also given another array. This is basically available apartment size. Okay, available apartment size. And we are given a number k, which is basically offset, kind of like offset. So what this offset do is we can assign a person, the ith person, the apartment, any one apartment, which lies between this range. Okay. So if any bj that belongs to this, so if any bj belonging to this, okay, uh, integer. So if this is the case, then we will assign it to the ith person, and we will increment the counter. So what I thought of was that when we are given both the arrays and all the other, like all three of these, okay, when we are given these, so my first instinct was to sort this both the array first. So after sorting, it will be like 45, 60, and then 60 and 80. This is the A array. Okay, and the available apartment size will be like this. So I will have a pointer to both the arrays and check whether I can assign this apartment to this guy according to his desires. Okay, so I see that k given or the offset given is 5, so I can assign 40 to 50 size apartment to this guy, but I don't have any, so I will just move away. I will move away from this. Okay, because if this since this is sorted, right? Since this is sorted, if this cannot be assigned to him, then there is no chance of this being like assigned to any other person. So we will not. So we will just move forward in the apartment. Okay. Then we see that again this number does not lie in this range. So this time, since this thing is less than this, okay, so there's a condition check. So basically, if this can cover, or if this is greater than this, okay, its range. If the apartment size is greater than its range, then we will move this pointer, and if it is less than this, then we'll move this pointer. So this is the logic. Okay, in simple logic. Did I? I think not. Okay, maybe I'll try with that. Okay. So yeah, so by doing that, we will solve the problem. So here, like you see that 60 greater than 50, so we will move ahead. We will come here. Now we see that I can accept 55. I can accept 55 to, let me change the color. I can select 55 to 65, and this comes in the range. So I will assign this to this and move both the pointers forward. Again, we see that this time also I can select 50 to 65, but the actual size is greater than its acceptable upper limit. So we will move this forward, and now I can accept this. Okay, so we will select this, and then the pointer will be at n or n and m. If its size is n, and if this one size is m, so when the pointer reaches n and m, so I will break out of it, and answer at the end of the iteration will be 2. So this was my simple logic. I tried it, but I don't think I did this one. This logic, like if apartment size is less than your lower limit, then move the apartment size pointer, or if the apartment size is greater than your upper limit, then move the person pointer. I don't think I did this. I simply moved the pointer forward uh, based on the desire itself, not the limit. Maybe I'll try that. Okay, so I'll try that. Who knows, it might work. So I have n, m and key. So m and key. I'll take input, and we have so yeah, basically we have mm, A array and B array. I'll take the input. Hmm. So okay, done. Then I'll sort both of them. Now that I've sorted it, I'll have two pointers, both starting at 0, and I will have a while loop which will go till Both of them. Oh no. Ah, it will go till any one of them has reached the limit. So I don't want any, you know, out of bound area access to happen here. So we will do this. Okay, what error do we get when we do this? I need to check. Hmm, very strange. Am I missing something? Segmentation what? Okay. But it is very weird actually. Why am I not getting any error? Hmm. I need to research. Okay. Anyway, so we'll do this. Where were we? The fuck. Okay. Okay. So if the current desire the current desired house, basically we'll check like this. I have the limit. No, let's say I have the upper limit. Mm, I have the lower limit. Mm, I have the lower limit, which is AI minus k. I have the upper limit, which is AI plus k. Okay. And if let me change it to a little also. And if the BI lies between upper limit and lower limit, answer will be incremented. Sorry. Otherwise, we have two choices. If BI is less than your upper limit, less than your lower limit, then we'll move the other pointer forward. Else, if BI is greater than upper limit, then we'll move the this pointer forward. And then we will do this. Should work. Oh, sorry. Hmm. Sorry. That is the thing now. It is J, not I. Hmm. Let's try to submit this. Okay. Um, I'm sure there is one or two, or maybe a lot of test cases that will fail. Oh, wow. Oh. Okay, I'll show you my yesterday's code. Okay. All the things are same. Only thing is that I was moving the pointers based on this condition, so it was wrong. Okay. Now we come to third. Ferris wheel. And children, Ferris wheel, gondola for each child. One, two children in it, condition the total weight in the gondola may not exceed the weight of every child. Minimum number of gondola needed for the children. Okay. Okay, so we need to assign gondolas based on children weight. Okay. It is um, um, very simple linear time algorithm will work here. Let me show you. Sorry. Okay. Next question. Hmm. Ferris wheel. Take the input. Easy question. So the thing is, we need to. Question is asking for us to divide the children in groups basically, so that the total group weight does not exceed the given limit. Okay, so that is basically what they're asking. So if the given maximum group limit of weight is 10 and we are given the weight list, what we can do is we can sort this list first, okay, and then try to compress the children's, basically try to make a group out of it. Okay, so we will keep a pointer here and then we will keep adding it till we exceed the weight. And the moment we exceed the weight, what we will do, we will increment the counter and then reset the weight to the current number only, because that is where the total weight exceeded that limit, right? So we cannot add the current member into that group. So what I'm saying is, suppose we have this now. The first group is having children two, the weight children with weight 2 and 3. The moment we try to add seven weight children, it will exceed the limit of 10 and it will reach 12, right? So what we will do, we will put a breaker here basically, and these two will be then added to the first group, and seven will be removed, and we will add seven in the next group. Okay. Similarly, when we reach over here, okay, so 7 and 9 is 16, again breaking the limit. So we will add a breaker here also. So then 7 will be mm, left, 7 will be uh, kept in a separate group then. Okay. So by doing this, we will have the basically group of childrens which does not for group of children where each group total children weight does not exceed the given amount. Basically, we can also call this the number of gondolas we need. Okay, so yeah, we will sort it. Okay, so we sorted it. We have the weight here, and what we will do, we will mm, we will keep a sum. Okay, so need a x cannot be 10 to the power 9, so integer sum will work here. But okay, it will not work. So sum is 0 initially. Okay, so we will add the sum. We'll add the weight to the sum. We will check if the sum exceeds the limit, basically x. And if it does, then we will increment the counter and we'll set the sum to pi only. And this should work. Okay, this should work. Hmm. Why I did that? Because basically by default we are initially creating the first group, right? So when we put a blocker or breaker here, we were already creating the first group, and after that this blocker came. We were done. We said that we have top two groups. Okay, so the answer was incremented to two. So initially it will be one. Should work. Okay, it did not work well. Should not exceed. should not exceed 15. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Or maybe 1, 2, 3, 4, 5, 6, 7, 8. Okay. It's not really simple. Or maybe we can try to do something like this. So in case of test case like this, huh? Let me draw it here. No, let me draw it here only. Okay. After sorting, it will become 5, 7, 8, 8, 8. I'll copy this. Okay. It will become this. Hmm. Now, what we will do, we will keep a pointer and we will ask in a map, pre-populated map, we will ask. Before that, we will remove this number and then we'll ask, can you find me a number which is, can you find me the lower bound of a number which is x minus the current number? Yeah, if it can, then we will check if the return number or if the number that was found actually equals, or of course it will actually equal only. If it equals to x, in that case we will keep both of them in a single group or single controller. Otherwise, what we'll do, we will we will put a blocker or put a breaker. Okay, so we can try this. Since I tried all the others, so why not this also? Okay, then I don't think we need to sort. It should work itself out. Okay, we need a map, and that map will have everything stored. Hmm. Now, I don't need some. Okay, so first I will remove the current number from map. Okay, after this I will search for the lower bound of the current number minus or x minus current number. Since x is always greater than or equal to pi, though, so it will not return give a negative number. From here. Okay, and if we will check if the value and the pi is equal to x. In that case, we will increment the answer. No, we will not increment the answer. Hmm. This will not work. Even if it works the way I'm implementing it, is will not work. It's my correct submission. The fuck? It's a two-pointer approach. Why is the optimal solution? It's let's try to try this. Okay. So we have I here, j here. We will check. We will run the loop until I is less than equal to. We will run the loop till I is less than equal to j. Then we'll check if I and j element are like less than equal to x. If that is the case, then they are in a single group. Okay. In this case, yes. So we will jump to the next one. And meanwhile, answer will be incremented to 1. Now it is 1. Again, we will see that it is not less than equal to x. So we will jump j here. So j is now here. Answer will be incremented to 2. Again, we will see that 7 and 9 are not less than equal to x. So we will jump here. So it will be 3 now. We see that 7 and 9 again is not, so it will jump to 4. We are here now. 7 and 8 are not are less than equal to the given number. So we will jump here. Again, it will be incremented. We are at 8 and 8, so it will be here. Okay, so now it is 6. Now it will be 7 when j is literally here. And in that case, since it is, you know, less than equal to x, we will do it as that. Answer will be included. This is the final answer. It works somehow, but I'm not sure why. It just works. I'm keeping them for my failed attempts. I think they have some new test cases. That is why I'm failing. Oh, I'm not sorting it. No? Hmm, okay, this will work. Of course it will. Because it is the same code. Concert tickets. I think we'll solve the rest of the problem tomorrow. I'm no sleepy. So we will we'll end the stream here only. And yeah, we will meet tomorrow. We will solve the remaining greedy problems and let's see how many we can solve tomorrow. Okay. So yeah, mm, good night and